Hi guys, Mr. Mackey here. Now yesterday we were doing percentage increasing and decreasing, and I set you this challenge regarding this leather jacket right here. When I first saw it in the shops it was worth £48, so I thought I'd come back a week later when I got a bit more money, but the price had gone up by 65%. I thought, you know what, I'm not gonna spend money on that, so I went home. The next week I was just window shopping and I saw this jacket on sale. From the price it was then, it went down by 30%. So I thought, you know what, I'm going to take the gamble, I'm going to buy it. How much did I spend on this jacket? So what we've got to do first is we've got to find out how much the leather jacket was when it increased by 65%. So how we do this is we first got to find what 65% of 48 is. Now what basic percentages could we use to help us? Well, we could do 50%, add 10%, add 5%. Because 50, add 10, add 5 gets us 65. So what is 50% of 48? Well, how you do it is you halve £48, and that will be £24. So let's write that here, £24. What's 10%? Well, we have our £48 and we have to divide that by 10. 48 divided by 10 gets us £4.80. So I'm going to write that here, plus £4.80. And then for the 5%, you just need to halve the 10%. So what's half of £4.80? Well, that will be £2.40, which I'll write here. So let's add that all together. £24 plus £4.80, that's £28.80. Plus £2.40, that will get us a grand total of £31.20. But we're not trying to find 65%. That's how much has been added to the original price. So what's £48 plus £31.20? That will be £79.20. You can obviously see why I chose not to get it. So the price that leather jacket was £79.20. And then I went back the next week and the price had gone down by 30%. And that's when I decided, you know what, I am going to get that jacket. So how much was the jacket at that price? So what we've got to do is we've got to find 30% of £79.20. What basic percentages could we use to help us? Well, what we could do is do 10%, add 10%, add 10%. Because what's 10 add 10 add 10? 30. So, what is 10% of £79.20? Well, remember, you got to divide it by 10, so 10% is £7.92. So we do £7.92 plus £7.92 plus £7.92, because we're doing 3 times our 10%. And now we add that all together. What's £7.92 added together 3 times? Well, if you add them all correctly, you would have gotten £23.76. So now we've got to take that away from £79.20. Now obviously I've done a lot of this, and this was a task I set you at home. So the answer to this simply is £55.44. So today we're going to be looking at indices. Now many of you probably have seen this word before, but you have definitely seen indices in your life. So what I thought I'd do is I start off with a quick question. What do these 5 numbers have in common? 1, 4, 9, 16 and 121. What do they have in common? You're not sure yet? Well, here's a little clue. Think about the times tables that these numbers appear in? Let me start showing you the answer. The only times table that 1 appears in is the 1 times table when you do 1 times 1. The number 4 appears in 2 times tables. It appears in the 4 times tables when you times 4 by 1. But it also appears in the 2 times tables when you do 2 times 2. 9 appears in 2 different times tables. The 9 times table when you do 9 times 1, but it also appears in the 3 times table when you do 3 times 3. 16 appears in 3 different times tables. No, it doesn't. It appears in 4 different times tables. Wow, see, it's even more mind-blowing. It appears in the 16 times table, 1 times 16. It appears in the 2 times table, 2 times 8. The 8 times table, 8 times 2. But it also appears in the 4 times table when you do 4 times 4. Can you guys notice something about all of these now? And what do you think 121 is? Well, I'll tell you it. It is in the 11 times table with 11 times 11. Now, all of these numbers are made by timesing a different number by itself. But there is an actual term for this. Do you know what that term is? These numbers are known as square numbers. And square numbers are numbers that are created when you times another number by itself. So 4 times 4, timesing 4 by itself, gets you 16. 7 times 7, timesing 7 by itself, gets you 49. And there's loads of square numbers out there. These square numbers go on forever and ever and ever. These are just the first few examples. Pretty interesting, right? But what on earth does that have to do with indices? Well, I'll tell you. Because square numbers are essential in indices. This is how you create an indice. We start off by looking at the number we're timesing by itself, which is 2. So we're going to write a 2 here. Now, how many 2's are we timesing in this problem? Well, there's a 2 here and a 2 here. So there are 2 2's. Keep up. And because of that, we have to write as a little number on top, a little 2. So this is telling us what is the number we're timesing by itself. And that is how many 2's are we using. So that is the same as that, which will get us that. And this little number here is an indice. Because this indice is basically a little simpler way of writing this problem here. It just means you don't have to write da 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 da, because there could be some really big ones out there. A lot like this. That is huge. So many 3's. I've given you the answer to it because that's a bit of a tricky one. 3 times 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 3. But I'm not asking for the answer. I want you to write this as an indice. So this is how we do it. Firstly, what is the number we're timesing by itself? Well, it's timesing by itself a load of times, but it's 3. And how many 3's are there in this problem? There's 1, 2, 3, 4, 5, 6, 7, 8. So it's 3 to the power of 8. That's the same as that, and that will get us that. That's all indices are. It's a simpler version of writing that, so we don't have to spend too much time filling up our sheet. Easy when you think about it. But what if we have an indice, but we're trying to find the answer to it? So what is 10 to the power of 4? Well, in this case, we will have to write it out, because this is quite a complicated one. That's the same as 10 times 10 times 10 times 10. We've done it 4 times. So now we have to solve this. So what is 10 times 10? Well, 10 times 10 will get us 100. That's our 10 times table. So that, we know, is 100. So what is 100 times 10. Well, remember whenever we're timesing numbers by 10, we add on an extra 0. So that is, from all three of these, that is 1,000. So what is 1,000 times 10? Well, what do we do again? We add an extra 0 on the end. So 10 to the power of 4 is 10,000. It's huge. Now here's another what do these numbers have in common question. I'm going to write 4 numbers on here and I want you to tell me what they have in common. 1, 8, 64 and 1,000. I'll give you a clue. What we just did with the tens is what gets us the thousands. The answer is that they are cube numbers. So square numbers are when the indice is 2. It's always going to be 2. Cube numbers is when the indice is always 3. So 8 is when you times 2 by 2 by 2. 64 is when you times 4 by 4 by 4, or 4 to the power of 3. So what would 3 times 3 times 3 get you? AKA, what's 3 cubed? That will get us 27. So indices can help us a lot by figuring out square numbers, cube numbers, and a lot of other different numbers. So here is a famous problem associated with indices. So the chess problem is thousands of years old, and this is your challenge for tonight. But the challenge is a simple story. There's a world famous chess player in India thousands of years ago, and he is challenged by the king of India to a game of chess. If the king won, the king will be named the world champion. If the pro wins, the pro will win riches for any desire. The pro won. So the king asked him, "What is your prize?" Now the pro was smart, and he said to the king, "Here's what I want you to do. I want you to look at the first square on a chessboard, okay? The first square, and put 1 grain of rice on it. Then I want you to look at the second square of the chessboard and put 2 grains of rice on that. And then I want you to look at the third square and put 4 grains of rice. And I want you to double every time." Now there are 64 squares on a chessboard. How many grains of rice will there be on the 64th square? Now, I'm going to be a bit nice. I don't want you to write down the actual number. I want you to write the answer as an indice. So there are 64 squares on a chessboard. If it doubles every time, how many grains of rice as an indice will be on the final square of this chessboard? It's easy when you think about it. That is your challenge for tonight. Good luck. Don't forget to subscribe, because it's important that we keep our children learning, especially through the hard times that the virus is putting us in. Thank you. Good night.